Hi students, few definitions and one important topic is order statistic and its distribution function of order statistics. First we are going to discussing about the nominal scale, ordinal scale, ratio scale and interval scale. So see the first definition, nominal scale. So nominal scale is the simplest measurement scale in which the objects are labeled with the help of numericals for their identification. It is the least powerful measurement scale which specify order or distance relationship of any object. So nominal scale is the simplest measurement scale in which objects are labeled. Labeling means you are all the computer students. Labeling means you are taking, suppose one represents male, so 2 represents female, suppose 0 illiterates, so means we are labeling 0 with illiterate, 1 with literates. So the best example in our daily life, so roll number 1, so particular student, roll number 2, particular student, so means we are labeling the student names with the roll number. So this is called the nominal scale, means we are representing the labeling with the numerical, so that's why we are counting the data, so that's why it is known as nominal scale. So in this type of measurement scale associates objects with categories and then describes the differences between them, hence nominal scale data is called as a counted data. So example, roll numbers assigned to a student for their identification. So this is the nominal scale. And see the ordinal scale. So ordinal scale is the lowest level of measurement which specify rank order of a particular event. This type of scaling is mostly used in research which are related to qualitative phenomena. Already we know that qualitative means qualitative. So qualitative means which cannot be measured, So that's why how can we measure? By ranking or by grading So that's why ordinal scale. So we are specifying, how we are specifying with the rank order of a particular event. This type of scaling is mostly used in where you are using this in research which are related to especially in qualitative phenomena. So the best example for this, one of the best example of ordinal scale is student rank, otherwise student rank. So for example, student rank in academics. Similarly, so even in Olympics, so ranks, we are giving ranks. Even in beauty contest, we are giving the rank. So this is called the, for this means ordinal scale is more suitable for qualitative data. So this is the definition of ordinal scale. And see the next one is interval scale. In that name only easily we can identify interval. Interval means some specific, from lowest value to highest value, some otherwise some minimum value to maximum value. That is the interval scale. See the definition. Interval scale is a measurement scale which is constructed by adjusting equal interval of units based on some standard rules. Means for example, thermometer for measuring temperature in Fahrenheit. So how much? So thermometer, so we are taking the general, the temperature level is 99 degree Celsius, 0 degree. So with the minimum is 0 degree Celsius and maximum is 99 degree Celsius in thermometer. More than, and general human temperature is 99 degrees, and more than 99 degrees are suppose for 101 degrees Celsius, 101 degree Celsius, 102 degree Celsius. So this is called the interval scale. And see the next one is, means we are measuring in thermometer, we are measuring degree Celsius or in Fahrenheit. So ratio scale. So ratio scale is a measurement scale that gives actual amount of variables in terms of some specific units. Statistical calculations and real number calculations can be done with the help of ratio scale. Ratio scale. For example, ratio scale is a commonly used for measuring physical dimensions like weight, distance, and height. So weight we are measuring in kgs, distance we are measuring in kilometers, height we are measuring in inches. So means some particular unit we are having with respect to the some physical dimension. So these are the main definitions you may get for short answers. So see the nominal scale, ordinal scale, interval scale, and ratio scale. So this is important for short answer. Then see the next short answer is order statistic. Next short answer is order statistic. So let us consider x1, x2, so on x and b, IID. IID means identically independent random variables of each with cumulative distribution function f of x. Now we can arrange the, what is f of x? Already you know that in the first semester only, capital F of x is the distribution function. Otherwise it is also known as CDF. CDF means cumulative distribution function. Now we can arrange the given observations into ascending order. So ascending order means small to big, 1 2 3 4 so on 10. For example, those are arranging in already ascending order, but in the place of numbers here we are taking the variables x1, x2, so on xn. So now we can arrange the given observations into ascending order of magnitude, that is x1. So x1 is 1 is already we know that 1 is less than 2. So x1 is less than or equals to x2, so on up to n random variables. So let XR be the R represents the rth order statistic. Suppose N means the nth order statistic. But here you are taking let XR be the rth order statistic whose PDF. PDF means probability density function. Already we know that probability density function is denoted by small f of x, but here we are focusing on the order. So that's why here you are taking the FRX, and its distribution function is all is denoted by capital F of x, but here we are taking with the rth order statistic. So that's why FRX is the distribution function of the rth order. So where we are applying this order statistic, it is used in the study of floods, droughts, as well as in the problems of breaking strength and fatigue failure. So in all the situations we can apply the order statistic. So this is the definition. So define order statistic means you have to write down the definition of order statistic and continuation, and along with that they may ask derive distribution function of the rth order statistic. Derive distribution function of the rth order statistic. For that I'm giving the explanation for the derivation. Let just now we define let FRX, where R takes the values 1 2 3 so on, and denote the cumulative distribution function of the, here we are specifying R, that's why we can say that rth order statistic, that is XR. Then the CDF FNX of the, FNX means n variables, FNX of the largest order statistics xn is given by a fnx equals to p of xn less than or equals to x. How you are getting this? Already you know that the distribution function is denoted by fx of x equals to p of x less than or equals to x. Based on this formula, here we are writing for n variables. So that implies fx and x is less than x. That implies n means n random variables. That n takes the values I is equals to. So that's why in the next step we are specifying p of xi. P of xi is less than or equals to x. Xi less than or equals to x, where I takes the values 1 2 3 so means we are expressing this expression in this way also. That means xi values I represents 1 2 3 so on, and in the place of I, if you are taking I equals to 1, so you may get 1 2 3 so up to n terms up to n terms. So that's why you are writing x1 is less than or equals to x intersection, x2 is less than or equals to x intersection, so on for n random variables. So but all are independent. So they given already in the statement, the definition they given IAD random variables. That's why we can write x1 is less than or equals to x intersection. So all are independent. That's why instead of intersection means we can write a product of the n random variable. That's why we are taking into p of x1 less than or equals to x into x2 is less than or equals to x, so on p of xn less than or equals to x. That's why here you are specifying x's are independent. So therefore, and our LHS is fnx equals to p of, according to the definition, fx of x equals to p of x less than or equals to x means, so then here you are writing x1 less than or equals to x. So that's why means that implies what you are having p of x1 less than or equals to x means you can write f1x. Suppose p of x2 less than or equals to x, so you can write f2 of x. So similarly here you are having p of x1 less than or equals to x, so we can write f1 of x. So similarly f2 of x on fn of x. So finally what you are getting, fn of x equals to f1 of x, f2 of x, so on fn of x. But in the definition we are taking x1 x2 so on xn are identically and independently random variables. That's why instead of 1 2 3 so on we can write all are equal, so all are having the same function. That's why f of x into f1x is nothing but f of x, f2 of x is nothing but f of x, because of this condition. So how many times it is repeated, the product repeated how many times, n times. That's why fn of x equals to, we proved that f of x whole power n. So in general, the cumulative distribution function fr means rth order, n means nth order. Frx of the rth order statistics xr is given by frx equals to summation I equals to 1 2 3 so on I equals to r to n nci f of x whole power I 1 minus f of x whole power n minus I. So by applying, how you are getting this equation, by applying the binomial expansion, it looks like in that way. So what is the mass function of binomial distribution, ncx p power x q power n minus x. By applying this p of x less than or equals to x means x variables are exactly x and one x1 variables are less than or equals to x, x2 variables are less than or equals to x, xn variables are less than or equals to x. By using that you are getting in this format. So put it as equation 1. So if you put r equals to 1 in the first equation, we get, what is the first equation, this is the first equation. Suppose if you are substituting r equals to 1 wherever r exists, so r in the place of r, if you are substituting 1, that is it becomes LHS is frx. So suppose if you are taking in the place of r equals to 1, that is f1 of x equals to I equals to, actually here we are having r, but we are taking r equals to 1, I running from 1 to n nci f of x whole power I 1 minus f of x whole power n minus I. In the next step directly you are writing 1 minus nci f of x whole power I 1 minus f of x whole power n minus I equals to 0. How you are taking this expression? Here you are taking I takes the values from 1 to n, but the leftover term is I starts from 1 to n, but and the remaining values are only 0, because the binomial distribution takes the values from 0 to n. So that's why already it is taking from 1 to n, the remaining expression is 0. So that's why, so p and that's why, so already you know that p plus q equals to 1, so q equals to 1 minus p, so the remaining term is I equals to 0. So in the place of I substitute I equals to 0, that is nc0 f of x whole power 0 1 minus f of x whole power n minus 0. So nc0 means 1, something power 0 means 1. So 1 minus f of x n minus 0 means n. So directly here you are writing 1 minus nc0 f of x, right? So then nc0 means 1, f of x whole power 0 means 1, 1 minus f of x n minus 0 means n. So 1 into 1. So finally what you are getting, 1 minus 1 minus f of x whole power. So minus 1. So this is the rth order, fr of x equals to 1 minus f of x whole power n. Similarly, if you take r equals to 1 in equation 1, we get summation. Whatever you are having in the place of equation 1, r equals to n తీసుకుంటే, then summation I running from n to n, nci f of x whole power I 1 minus f of x whole power n minus I. So then, so overall the terms are only n. So that's why just in the place of I equals to n, ncn f of x whole power n 1 minus f of x whole power n minus n. So n minus becomes 0 f of x whole power n. So 2c2 value is 1. Again 1c1. So similarly ncn value also 1. So f of x whole power n 1 minus f of x something power 0 is 1. So finally we are getting f of x whole power n. So means what we proved, that fn of x equals to f of x whole power n. So this is the derivation of distribution function of the rth order statistic.